Hello friends. An objective of a session is not about knowing Bitcoin or Ethereum smart contracts, but to understand what exactly blockchain is all about and how blockchain has evolved in the course of time to become a platform for different applications. We will be talking little bit about Bitcoin and Ethereum and other coins to know that how the blockchain has got evolved. Before we start with the blockchain, let us understand what Jack Ma Yun, who is a co-founder and executive chairman of Alibaba Group, has said once. It is not the technology that changes the world. It is the dream behind the technology that changes the world. Very well said. Let us discuss some products which are introduced through a blockchain technology or a concept and will help in understanding a blockchain in a much better way. In 1991, the two computer professionals, Scott Haber and W. Scott Stornata, worked on some cryptography concept to cryptographically secure a chain of blocks or an array of collection of documents connected through a pointer. A year later, in 1992, they again came up with an algorithm called Merkle tree to manage the document within each block and helping in collecting multiple documents in a single block in a more efficient way. We will talk about Merkle tree in a separate session. Years later, in 2008, an unknown person named called Satoshi Nakamoto came up with the concept of digital currency by using the technology related to building of blocks, cryptography along with other set of rules. He want to solve a problem of double spending. For example, you want to send your hard-earned money, say $10 to your home country. But to send those $10, you have to deposit it to your bank. And that bank, with the help of intermediaries, will send it to your home country bank. During the whole course of transferring of money from one bank to another, it has gone through a single or multiple agencies or parties, which will take their commission, and that commission will be deducted from your money, which is $10. Also, there could be a possibility that the money is not reached to its destination, as therefore to eliminate all the third parties in between a transaction, he came with a product called Bitcoin, which is also known as cryptocurrency. In January 2009, a first Bitcoin or a cryptocurrency was introduced in the form of electronic cash. There is no central body or third party involved between a sender or a receiver, which makes an amount being transferred between user to user directly. He utilizes the group of computers which are present on the network to generate and transfer the amount. We will talk more about decentralized and peer-to-peer in the upcoming slides. The support of peer-to-peer network has removed the intermediaries from the process and making a transaction more fast, secure, and trustworthy. So the main purpose of understanding a Bitcoin is how effectively Satoshi Nakamoto has used the existing technologies along with his own set of rules and algorithm, which has helped in solving the problem of double spending and also help in the introduction of cryptocurrency to the world. So after a Bitcoin was in the market, so as its code is also available in the market, so there were a lot of vendors and developers or individuals who started building altcoins and introduced the ICOs, which is also called as initial coin offering. And we will discuss it in a separate session and also compare it with the IPOs. So these altcoins have the underlying architecture of Bitcoin and have a similar kind of features. So these applications which are based on the altcoins are meant for the single purpose utility means they can only do one type of work and have the underlying Bitcoin architecture. Okay. Example of such altcoins are Litecoin or Bitcoin Cash. So in 2012, another group came up with a concept called Mastercoin, which introduced the two-layer protocol, okay, and later become the competitor for the Bitcoin. So Mastercoin is a two-layer of protocol which uses a Bitcoin protocol layer as a currency layer, and on top of it, it added a new layer where a new set of rules can be applied. So this new set of rules will help in extend the properties and the usage of cryptocurrency by different ICOs. For example, HTTP protocol run on top of TCP/IP protocol. If you see in this current diagram, we have this Bitcoin protocol, okay, which is unchanged. So they have unchanged this whole Bitcoin protocol, but what they have introduced the new set of rules. And now combining these two protocols, the developers, the vendors, and everybody can use new currencies or create their own currencies and add their own features on top of it. Okay. So the message to the whole world was given by Metacoin and was that the cryptocurrency can be issued with the new set of rules and making applications based on cryptocurrency with more innovations. Let us talk about Ethereum, which is another product built on blockchain technology or a concept. Before we even talk about the Ethereum, let's talk about Vitalik Buterin, who is a co-founder and developed the Ethereum on the blockchain platform. He is a computer scientist and an article writer. So Vitalik Buterin in 2011, okay, met a person, okay, and on a Bitcoin chat forum to write an article for him. So he was offered 5 Bitcoins at that time. The Bitcoin price was $3.5, which was nothing. So he started writing articles for Bitcoin chat forum, and then in 2011 September he met another person, and he asked him to write the new articles or the publications for the Bitcoin magazine. So during his tenure at the Bitcoin magazine, he realized that blockchain technology can be used beyond cryptocurrency. Now we see how the blockchain technology is evolving and the thought behind the applications is getting changed and getting advanced. So what he thought that, okay, this blockchain technology is not only can be used for cryptocurrency, but can also be used for many other things. The protocol on which the Bitcoin is built is used to do the specific task. Even there are other applications which were built on the blockchain concept was to do the specific task. So for example, Namecoin, so which was built on the Bitcoin concept, and they were doing the domain registration and storing a bit more information so that the information can also be stored on the Bitcoin blockchain, also making it not much a difference. There is another coin called Prince coin, which is used for a scientific purpose, but all these coins were only doing the specific purpose. So his thinking was very much beyond the cryptocurrency, and so when he read about Mastercoin, which he also called it as the second generation protocol on the blockchain, and we have already discussed about the Mastercoin, He got an idea on extending the blockchain for more use cases, which can be used for other technologies. So in 2013, he came up with an idea for building smart contracts, whose main intent is to digitally facilitate, verify, or enforce the negotiation or the performance of a contract without any third parties, and also making this transaction trackable and irreversible. So he started extending the blockchain on the based on his requirement. So he started adding new set of rules, and also which can be used with the other technologies. So in late 2013, he came up with an idea. So the system went live on 30th July 2015, and he introduced the coin called Ether, which helps, or we can also term it as gas, which helps to run the Ethereum or the smart contracts on the Ethereum platform. Let us again look at the statement of Jack Ma Yun, and whatever we have seen, all the products of the blockchain like Bitcoin, Metacoin, and Ethereum. So these are not the technologies, but they are the dreams basically behind the technology of each and every individual, which is changing the world. So unless and until you don't have any concept or the dream or what you really want to build onto the technology or onto the concept, it won't even matter. It when it matters, when you make a product like Bitcoin or Metacoin or Ethereum or any product onto the blockchain or any other technology, then only it will make a sense. So far, we have seen products and applications which are built on the blockchain, which also raises a lot of doubts in our mind. Like, is it a database or a ledger? Is it a protocol? Is it the key value pair storage where we can, just store the values and we can um, extract the values based on some key or a public key or a private key? Is this blockchain a public or is it a private or is it a hybrid where it can be stored? Is it decentralized, and why it is decentralized and why not centralized? If it is centralized, then what could be the advantage or the disadvantages? Can data be updated or deleted? As we have seen, people can create their own set of rules onto the blockchain protocols, and they can have their own products on the blockchain. Or if there are multiple blockchain, can we there be any relationship we can maintain? Or if we can maintain the relationship, can we merge different blockchain on top of each other, like we merge the database? So we will have all the answers in the coming slides. To answer questions from our last slide, let us understand in detail about the blockchain. I have divided the blockchain into two parts. Firstly, into a block and another one as a chain. Let us first understand about a block and what does it contains. A block in a blockchain is a container for a data structure. Based on the type and the complexity of our application, we can define a data structure in a block. Typically, a block contains a block number, which defines a number of a specific block within a chain. This block can have single or multiple transaction information in an encrypted format. Timestamp can also be added to a block to know when a block is created. We add another property called nonce. Nonce is an arbitrary number that can be used just once. It is a random number which is used in an authenticated protocol to make sure that it cannot be reused in a replay attacks. It's a kind of a network attack. And we add the information about the previous block, which help in maintaining a chain of a block. When the first block is created, which is the zeroth block, we call that block as a genesis block, and its previous block value remain as 0. All the other blocks are linked together through the value in a previous block. In, in the later slides, we will see who builds a block. Also, one block in a Bitcoin takes 10 minutes to get created. So all the transactions, all the values within one block. So Bitcoin takes 10 minutes to create a one block. But for the Ethereum, it takes 15 seconds to get created. It is the based on the protocols, the set of rules, or the type of data we are trying to add it, and the complexity. Based on that, it takes the time. We will talk more about Bitcoin block and as well as Ethereum block in our next slide. As we have learned about a block, and we have learned that it is a container for a data structure, let us see what the Bitcoin block contains. It contains a magic number, the block size, the number of bytes following up to the end of the block. So the size of the block header, which contains another 6 items within that, the transaction counter, and the transaction. It's a non-empty and has got the list of the transactions. Okay. This block header has contained now 6 another properties, which we call it as version, block version number, hash of the previous block, which is the 256-bit hash of the previous block. When a new block come into the picture, it has to come into the chain and it has to link to the previous block. So what happened? The previous block number, okay, it gets encrypted into the 256-bit hash and it gets added over there. Then we have an hash Merkle root, okay, where we tells the transaction is accepted, and it happens when the transaction gets accepted with the 256 bit of hash. Okay, time is a current timestamp associated with the specific block. Okay, and then there is the bits, is a current target in the compact format, the difficulty which is adjusted. So this bit terms as the difficulty is a number which regulates how long it take for a miner. We will discuss about the miner in our next few slides. So the difficulty is a number that regulates how it takes for a miner to add a new block of transaction to the blockchain. And in the blockchain, the difficulty value updates every 2 weeks to ensure that it takes 10 minutes to add a new block to the blockchain. And why this difficulty number is important? Because it ensures that the blocks of the transactions are added to the blockchain at the regular interval of time, when even though the more and more miners join the network. So don't worry about the miners, they are just the processors or the uh, computers which generally process the data, and they help in creating the block to get added into the chain. So we'll talk a little bit about the miners in our later slides. And then we had a nonce, as we have discussed, it's an arbitrary number. We will also look at the Ethereum block. What does this Ethereum block contains? It is header, okay, which is the pointer to the header structure, which contains 59 terms. We will see in detail what this header contains. Then there is an field property called uncles. It is an array of header pointers. Then the transactions, all the transactions which it contains. It gives the hash, the size of the specific block. TD is used by the package code to store the total difficulty of the change up to and including the block. So it's a difficulty, like when the block needs to be added. Then received at is the use by the package either to track interpret block relay and receive from. So these are the addresses from the receiver and from where it has got added. In the header, we will see like parent hash, uncle hash, Coinbase, root, transaction hash, a TX hash we call a receipt hash. So whenever the new block is added into the header, the information is added in, there is a receipt which gets generated in the hash format, bloom difficulty, number, gas limit, okay, how much is the gas limit, which the ether which is used to generate the execution of the smart contracts on the Ethereum platform. Then how much the gas is used by those smart contracts or the specific transaction, the time, the extra, the digest, and the nonce, which is again the arbitrary number to so that we can avoid any network attacks. So far, we have seen what does a block contains. Before we look into who builds a block, let us understand some concept of different type of network involved in the blockchain. Blockchain is built on a peer-to-peer network, but please remember every peer-to-peer network is not a blockchain. Peer-to-peer network is defined as a multiple computers connected together in which each computer can act as a server, allowing shared access to files without a need of a central server. There are another kind of networks or another type of networks. Let us understand those. Centralized network. It is a type of network where all the users or all the nodes or all the computers are connected to a central computer like this. So this is the central computers. Every node is connected to the central computer. In the blockchain, the nodes connected to a central computer can act as a miner, but the information is stored in a central computer. The copy of the transactions are maintained on a central computer and is only accessible by the admin or those who have got access to the central computer. In this, a centralized computer has a power to take a decision. Another kind of network is the decentralized network. So in the decentralized network, so what is happening? It is a subset of a larger group of a trustless network. So the nodes in the decentralized network make a decision themselves based on some consensus without any centralized making authority. In the decentralized network, nodes can come and go and there is no permission required to join the network. This is also considered as trustless network. There is no trust required among the nodes as it is required in the centralized network. Each node is expected to act as per consensus. So if you see, this is all the central, these are all the nodes, and this whole makes one big nodes, okay, and all are connected, and every node has got his own power, okay, and use the consensus algorithm, okay, to create the block or to take the decision or to process the information or the transactions. We have gone through what a block contains, but who creates a block remains a question. It depends on what type of infrastructure we want an algorithm to run for the creation of a block. So in the centralized network, okay, the nodes connected to the centralized server can get authorized to use their processing power to run an algorithm which helps in the creation of a block and then store it to the specific node or to the central server. The central computer can extend its power to reject or accept a block. There is some authorized body which will have a control over a transaction even though they are in an encrypted form. In a decentralized network, it can be anyone in the decentralized node to lend its processing power to process a transaction and create a block which can be later added to the node, which can be anyone's computer. Okay, so multiple copies are stored on multiple nodes. If there is any tamper with any of the block by any node, the other nodes will reject that block. We will learn more about how the blocks are added to a chain in the later slides. So the nodes or the computers who process the blocks are called miners, and the process of creating a miner is called mining. Each miner is rewarded based on the consensus algorithm. An algorithm to mine a block can be different for each blockchain. Miner has to solve a complex puzzle to create a block which contains all the transaction. For example, you can say as algorithms like proof of work or proof of stake algorithm can be adopted by blockchain creators to process a block. So there are a lot of consensus algorithm available or you can either create your own algorithm. Proof of work is a consensus algorithm where any trustless node can use its processing power to create a block in a blockchain and can be rewarded if their block is accepted through confirmation by different nodes. Whereas the proof of stake consensus algorithms allow a person to mine a validate a block according to how many coins he or she holds and act as a trusted miners. There are other lots of consensus algorithm as I have told earlier, which can be used for mining and validating a block. So far, we have seen how a block is created. This slide, we will see how we can add a block in a chain. Once a block is created by the miner, it is validated by the other miners. These blocks are stored on someone's computer on a decentralized network. And in a centralized network, it is generally stored on a central server. Each block is connected to the previous block using the hash key reference or previous block except the genesis block, which is the 0th block. Once the blocks start connected with each other, a chain of block gets emerged. Each node has a copy of all the transactions ever made in a chain. All the nodes are updated in a transaction, and these nodes, as said, are validated by the miners based on the consensus algorithm. So in a decentralization, the copy of blockchain is present on the each node, and all the transactions, all the nodes in a decentralized or the are updated to have the latest transaction and the blocks. So now the question comes, what happens if more than one block with the same transactions are available to be added into a chain by different miners? blockchain follow the concept called longest chain rule, which we will be learning in our next slide. Let us discuss about the longest chain rule. The chain with the most work or blocks is recognized as a main chain in a network. Let us say we have a block on a blockchain. So 0 is a genesis block. Okay, that's the first block. And then we have a lot of blocks till 51. And 51st, 51 is the last block in the whole blockchain. Okay, so there is an A miner which detects a block 51 and started adding a block on top of 51. And at the same time, miner B and miner C also started building a block on block number 51 as they see the latest block on the chain. So miner A is completed with its block and ready to be added into a blockchain. And also a few seconds later, miner B and C is also done with their blocks. Okay, so let's say 52B and 52C. So you see there are three blocks which are all ready to be added into the chain, but we don't know which one will be added. Out of all three blocks, let's say 52B got the higher number of confirmation based on some logic or algorithm. So 52B will get the confirmation on the chain on which he has to build the another block. Okay. So once this 52B gets a confirmation, the other two 52A and 52C will get rejected. Okay, and the block will be linked to 52B. So when another miner detects 52B on the chain on which he has to build another block, that miner will disregard 52A and 52C as they don't belong to any longest chain. Thus, the accepted chain will be 50, 51, 52B, and then 53B. Okay, and so on. Okay. The confirmation may vary based on different algorithms and rules adopted by different blockchain or vendors. The higher confirmation will be accepted as a block. For example, for a Bitcoin block, at least 6 confirmation is required to be accepted into a chain. So far, we have read about the applications which are built onto the blockchain, how the blocks are created, what the block contains, and how the chain is gets created from the blocks. But now let's see some of the properties or some of the features which is making a blockchain more favorable and accepted by the industry. So first one, we will look into the consensus. I am being using this word consensus most of my time during my previous slide, but let's see what does it consensus contains. Okay, so consensus is a process. It is to achieve an agreement on a single data value among a distributed systems. It's kind of an agreement. Okay, if I have to buy something from you and I have to pay you for that particular product, so there is some specific agreement which will come into the picture. So there is an agreement on a single data value or a product which I am going to buy from you among the distributed system. Then there is to achieve a reliability in a network in terms of computer language where unreliable nodes are available. So as we have seen in a decentralized network, there are a lot of trustless nodes which are connected, and those nodes creates the block, and we don't know whether those blocks which are created are they corrupted with some data, or they are being hacked data, or something which is fishy around those blocks. So the consensus is defined to achieve a reliability in a network where unreliable nodes are available. Then since unreliable nodes are getting added and the system is complex, so there has to be the fault tolerant. So what is this fault tolerant in a computer system? It is a concept where the system should continue working to the level of satisfaction in the presence of errors or breakdown. So that the system should not fall into pieces. So how it is helping the blockchain? It helps a blockchain in making all the nodes, especially in a decentralized systems, to agree on the certain principles. So let's say I am having a group of people, okay, and they have to come within a specific decision. And if we don't have any rules to follow, everybody will have their own way of saying, own way of thinking, and they want specific result in their own favor or in their own way. So if we put up some rules, okay, in place, the every person within the group will follow that rule, and the result or the decision or what we really want from that discussion will come into the concrete picture in a well-defined manner. Also, consensus helps blockchain in arranging all the blocks in the blockchain with the flexibility and in a secured way. So we have seen the longest chain rule, okay, the we have seen how the blocks gets added into the whole chain to make it a whole blockchain. So consensus also help in making the blockchain with a more flexibility and in a very secured way. So example of a consensus algorithm that we have already discussed a few things about, like proof of work, which we call it as POW, proof of stake, which is POS, and then DPoS, which is a delegated proof of stake. And there are a lot of algorithms which can be adopted onto the blockchain. You can also create your own consensus algorithms, and if you want to create your blockchain from the scratch or use the existing algorithm. Let us talk about another feature of a blockchain, immutability. Immutability is something which we cannot change. Once written, it cannot be changed. Like in our traditional databases, we have a CRUD operation like create, read, update, or delete. So in this, we cannot update and delete. What I mean is we cannot update and delete in a blockchain, but we can create and read from the blockchain. So since the data is stored in a block, and block is a part of a chain which is on a multiple nodes, so it becomes very difficult that it cannot be faked or altered. As we have seen, when the block gets created, okay, they need to have the confirmations, okay, based on some consensus algorithm. And once the confirmations are given to the block, it get attached to the chain, okay. So when a new block is added to a blockchain, it follows the longest chain rule, which makes a data to be altered or deleted more difficult. Okay, so let's say if we have a power, and we can create some particular miner can create their own longest chain. So at least 51% of the blockchain blocks needs to get changed to update any data in a block. Okay, so when the chain gets increased and the chain becomes bigger, it's very impossible to change the block or the data inside the blocks, because it requires at least 51% of the blockchain blocks which needs to get updated. Since the data processing is so expensive to process all the transaction and all the blocks, which can make a longest chain become practically impossible. Let us talk about the another important feature of a blockchain, security. So blockchain uses encryption. We have seen the data inside the block.
it gets encrypted into the hash code, which makes the data within the blockchain to be decrypted in a very difficult manner, as hashes are generally one way, and if you want to decrypt it, it is very difficult or next to impossible. So public key and the private keys are used to access a data in a blockchain. Since it is public in a decentralized, okay, so it is public in a decentralized in a nature, and it is on the P2P network. Therefore, it is difficult for anyone to breach a blockchain. So in a decentralized network, we have multiple nodes, if trustless nodes, which are connected, and there is a consensus algorithm which helps in building up the blocks, and the confirmation is required to make sure that the block which is created is trustworthy and can be added to the chain. So it's become very difficult from the hacker from the for the hacker and from the network point of view to change a specific block or a data within a block. A blockchain follow longest chain rule, which makes it difficult to hack a data for any update or delete. For blockchain in a centralized environment, the security of a blockchain remains within an organization based on the rules they have adopted for a blockchain. As we know, centralized has got a central server or an authorized body, okay, which will accept a block, or the it will authorize the nodes which are used for making up the blocks. So the authority remains with the centralized organization, and it is up to them how they are adopting the rules and how much security they want onto their blockchain. So let me summarize what we have read about the blockchain in a briefly manner. So it is a technology or a concept. So based on our adoption, if we are using someone uh, else blockchain, or somebody has created a blockchain like Bitcoin, Ethereum, or Metacoin, and we are using their technology, which is based on the blockchain concept, then we are using the technology. Otherwise, if we are making something from the scratch, okay, and we are adding all the algorithm or creating, then we can use this blockchain as a concept to create our own blockchain. It is a block with a collection of the data. So we have seen the blockchain, okay, is a collection of a data inside the block, and we can say it is block is a container for any data structure. So multiple blocks are chained together based on some algorithm, and we have seen those algorithms are the consensus algorithms based on P2P network where processing and data is stored. So we are using the processing power of those nodes or the computers which are connecting within the network, and the data is stored onto the node. It can either be decentralized or centralized with, and when we say centralized, it may have some limitations. Okay, people may trust or people may not trust. Okay, in the centralized environment, as the authority in the centralized environment is only restricted to the central authority. But in the decentralized, since it is a public, this and the all the nodes has to work within the consensus. Data can be encrypted using a hash algorithm, example SHA-256, to make a data more secure. Some rules can be applied for processing the data, which we call as protocols. So we can add our own set of rules, or we can, if we are using someone else blockchain to create our own applications, then we can use their set of rules, which can be easily adopted. Also, we can enhance the blockchain in terms of with a new set of rules or the protocol. We can add more algorithms, or if we want to create our own algorithm instead of the existing algorithms which are available for building up the blockchain or for the consensus and all, we can have our own algorithms rather than to use the existing ones. Security, we can add our own security the way we want to encrypt the data so that we can enhance it since it's a concept. And if we want to adopt another set of protocol, or we want to add the layer of the protocols on the existing blockchain, like uh, Metacoin has done it for on the Bitcoin, where Metacoin has set up the second layer of its own protocol on the layer of the Bitcoin. Okay, so you can also put up the security or the rules or the algorithm on top of the existing ones. Scalability, so how you want to scale your blockchain. Okay, storages. So the data is stored onto the node, but there are blockchain databases which are available in the market. So you can, when you are making a blockchain, if you want to create your own databases, okay, which can reside on the node or onto the central environment or to the central server, we can even create our own storages as an enhancement. In a blockchain, there is a consensus. The message cannot be changed, which is immutable. Message is secured from an authorized party and it is authentic so that it cannot be altered. Message is stored and verified through different sources as in decentralized. There is a validation and verification process involvement which can lead to a trust. So let's see how we can now have a definition of a blockchain, what we have read so far. So, what is blockchain? Technology on which we can build consensus-based application by storing an immutable information on a secured decentralized platform which create a trust between different parties is called a blockchain. So, in the starting of the slide, we have discussed when we were talking about different applications built up onto the blockchain, then we have found that there might be some multiple doubts which has came up in the mind, and see if we were able to answer those doubts or not. Is it a database or a ledger? It's a distributed ledger database, or we can also call it as distributed ledger transaction, which is known as DLT, containing records of cryptocurrency transaction or crypto data inside the block. Is it a protocol? Yes, it contains a set of rules. Is it a key value pair storage? Depend on the set of rules we have defined inside the block or through the consensus algorithm. Is it public or private or hybrid? It can be decentralized or centralized or both, as an hybrid and the centralized both. Is it decentralized? Yes, it is decentralized if we want to have a fully trusted blockchain. Can data be updated or deleted? No, it can be trackable based on public-private key, but it is irreversible. So blockchain doesn't have any CRUD operations like we have in traditional RDBMS or traditional databases. Can there be any relationship between different blockchain? No, as different blockchain may have different set of rules or protocols which may not be compatible with each other. Can two or more different blockchain merge? No, as different blockchain may have different set of rules or protocol which may not be compatible with each other. Therefore, we cannot merge two different blockchains. Thank you very much for listening my blockchain presentation. I hope this will benefit you. You can connect me on my LinkedIn account, which is www.linkedin.com/in/ckbhatia. And if you have any queries, you can send me a message, and based on my availability and time, I will be able to answer to your queries. Thank you.